Hey guys, BuildZoid here, and today we're going to do something that I haven't done in a very long time. We're going to do an overclocking guide, my way. So we're going from, we're going through the whole process. I'm not going to cut anything out. We're going to have blue screens, we're going to have crashes, we're going to do everything that I normally do, and obviously I don't edit. That's the main reason why I'm not going to cut anything out. So yeah, this is going to be a long one. But I have a 10700K here that I've never overclocked before. This is literally the first time I'm running the CPU, so you get the new CPU experience. Because the thing is, there's a difference between sort of like I don't like it when you have overclocking guides where it's like I already know what the CPU does, so I'm not actually going through the correct overclocking procedure. I'm just punching in magic numbers and they just happen to work, right? Like I'm not really a fan of showing that. So we're going to go from literally from zero. I've never run the CPU. I've not really even run this motherboard that much, or the memory sticks. I've run other motherboards in Gigabyte Z490 lineup, so it's not like that I have no idea how to navigate it. But yeah, anyway, so we are going from sort of like as new a build as possible for me. So yeah, hardware-wise, we have the Gigabyte Z490 AORS Master, so huge thank you to Gigabyte for providing the motherboard. This is really overkill for a 10700K, but I really wanted the post code, so that's why I went with this board. I could have also gone with like the Extreme, but that, in my opinion, would have been even worse in terms of overkillness. The memory kit is Team Group's T-Force Extreme ARGB 3600 CL14 memory kit. This is, I also have this kit as a review sample from Team Group, so, thank you to them for the memory, but this is a really, solid sort of memory kit to start with, because it's 3600 CL14, so it's pretty much guaranteed to work. 3600 megahertz is not that hard to run. CL14 is very low latency for 3600 megahertz, and, because it's 3600 CL14, it also has an absolute ton of overclocking headroom, and these are just 8 gig DIMMs, so this is just a 16 gig configuration in total. The CPU is cooled by a 240 millimeter AIO. There's Kingpin cooling KPX under for the thermal paste. The power supply is a Corsair HX1200, which is also massively overkill. I don't really have an adequately sized power supply for this kind of thing. Like, all of my test bench power supplies are 1000 watts plus, because sometimes I want to run 4 GPUs, and when I do that, the smaller power supplies get very upset. The GPU is a GT1030 because we're not overclocking the GPU, so I just need something to, output a display signal. And you'll notice that I don't have the second 8-pin power connector populated, and this is on purpose, because this is a 10700K. There's no need to plug in both 8 pins. The second 8 pin is completely unnecessary if you're on a 10700K. So yeah, we just have the single 8-pin power connector because you don't need the other one. So yeah, BIOS version is F6B. I've updated the BIOS before starting this video. As you can clearly see, I've just reset the BIOS because I ran into some technical Windows difficulties on the previous take of this video. So I did have to reset the BIOS, yeah, but it already put me into advanced mode. So normally, if your first time ever booting the board, it would throw you into this menu. This is easy mode. You press F2 and you get out of easy mode. Then for fan controls, F6. So you can choose between the various fans. I only have CPU fan optional and CPU fan plugged in. CPU fan optional is the actual AIO pump. The CPU fan is the fans on the AIO. I have a relatively high noise tolerance, so I'm just going to set everything to full speed, which is what the Apply To menu does here. And you can navigate everything in the fan control menu with the keyboard, which I really appreciate, because there are some motherboards that force you to use the mouse in the fan control menus, and in my opinion, using the mouse in the BIOS is wrong. So I do appreciate that Gigabyte agrees with me on that, and, they make it possible to use the keyboard absolutely everywhere for everything. Anyway, so now we're going to enable the extreme memory profile. So I'm just going to set profile 1, which is at 3600 CL14 at 1.45 volts, which is just fine. So we're going to save configuration and exit, and we're going to run the system just all stock, see what kind of temperatures we're running, that kind of thing. Now, this is a 10700K. I don't really expect it to run that hot. especially since I don't believe Gigabyte has any like multi-core enhancement stuff running, unless you enable it. So yeah, this should be running very, very cool right now. So the issue I was previously having was that it wouldn't go to 1080p. But now we have my favorite issue, which is the capture card deciding that it doesn't like the GPU. So, yay. Well, that didn't bloody fix it. Why do I keep trying to use NVIDIA GPUs? Like, AMD GPUs don't have this problem with the capture card. It's just the NVIDIA ones. Okay, well, I'll see if I can... Like, I'll try do something to display. No, that's not what I wanted. Man, I don't normally use NVIDIA GPUs. I have no idea what I'm setting here. Okay, well, now the colors look correct. So if you were wondering about that, if you're going on HDMI on NVIDIA and the blacks look washed out, that's what does that. For whatever reason, NVIDIA likes to default your colors to washed out. Hopefully that fixed the capture card issue. I have no idea. I've never actually messed with it. So for software, I like using CPU-Z just for checking like CPU stock behavior, or well, for checking like memory settings and CPU settings and that kind of thing. CPU-Z is great. Then for actual like temperature and voltage monitoring, hardware info, this is version, whatever version it just popped up. Version 6.28. What's cool about 6.28 is, yeah, we have that. So we have these sensors all the way down here for Gigabyte motherboards, and this is really useful because that right there, so this voltage reading right here, is the actual DyeSense Vcore voltage reading. So that's a very accurate core voltage reading that you get directly from the voltage controller. So if we run something like, say, where's Cinebench? Where's R20? Where did Cinebench go? Like, I know for a fact that I have Cinebench on this system. I guess I don't have a shortcut for it. Well, let's quickly make one. And now it's going to tell... No, there apparently wasn't a shortcut for it. So, yeah, we're just going to run Cinebench as a baseline for our performance. I'm just going to pull that down. This here. And the thing is, we should see a pretty major voltage reading disparity when Cinebench runs between this sensor and then, like, this sensor right here. Or maybe we won't. Oh, that's interesting. For once, the voltage readings in the CPU... Oh, wait. Yeah, it's floating up. Yeah, so the problem here is... So right now, we're not pulling a lot of current, right? It's just 123 amps, and that current draw reading right there is actually quite accurate. You can trust that kind of a lot. Other power readings, not so much necessarily. Well, like this, all of that is broken right there, so that's great. No, I don't want to move anything. I wanted to highlight them, but... Forgot that hardware info doesn't let you do that. Anyway, so right now we're running like 4.7 gigahertz. Heading about 60 degrees. It's cool. So we do seem to have some amount of like performance enhancement running. Yeah, so there's a bit of a voltage disparity, and the voltage disparity is caused by where the voltage measurement is being taken. So CPU-Z will normally be polling the Super I/O, which is a chip that measures the voltage going to the CPU on the CPU socket, whereas the Intersil ISL 69... so, wait, oops. Well, that was what I wanted, but now I closed hardware info. Oops. So, let's just get hardware info open again. So the thing is, the ISL 69269, that voltage reading is from the actual silicon of the CPU. So that's why there's a bit of a voltage difference, voltage reading difference, right, between like Vcore up here. This is almost matching what CPU-Z sees, but this is a couple millivolts lower. And that's just because there's a voltage drop across the CPU socket. And Cinebench, like right now we're at stock settings, so we're not pushing that much current. Cinebench also doesn't pull that much current, so yeah, anyway, stock score was 4771, or around 4771, and yeah, so now we're gonna run, well, so for actual stress testing, I like to use Linpack Extreme. It looks like this. It's kind of annoying to use, but you just go 2. And then I like to, so for 16 gigs, I would test at least 5 or like setting 5, so 10 gigs of memory. And then we're just going to be doing, well, we're not actually going to run this version because this is going to take forever right now. But then I normally run it, like I'd run it for like 30 minutes to an hour if I was going for a full stress test. We're not actually going to be running it that long because it does take forever. Alternatively, Prime 95 is also a perfectly good stress test. It's a little bit less intense compared to, like, so Prime 95 is better at, like, getting your CPU really hot and keeping it really hot for a really long time, whereas Linpack load cycles really hard. As in, it can get, like, the peak power consumption of Linpack is higher than Prime 95, but the average power consumption is actually lower because it doesn't sustain that peak power consumption for as long. Anyway, I'm just going to quickly run 2 gigs, and we're going to run that 3 loops, and yes, yes, and no. And then one trick to see if Linpack is starting is to just watch your memory usage, and I just realized that I have max mem set on this, so that's not going to work. Yeah. So this operating system is configured for extreme, like I forgot that this OS is configured for extreme overclocking, so I had like a bunch of memory disabled. That's why I didn't want to run Linpack. Restart. Anyway, well, now I guess we'll see if the capture card figures out how to initialize the GPU proper. Well, if the GPU agrees with the capture card for once. And it doesn't. Go. Oh, and I screwed up the HDMI. Okay, so now if we get hardware info open, want to run, and we're going to run 2, and we're going to run it 3 times, and yes, yes, no, enter. I'm going to go. And the thing is, you can see that your memory usage starts increasing, and once it hits a certain level, that's when the workload actually starts properly, because Linpack spends a lot of time just going up to the appropriate memory usage. So now that it's started, where's our CPU temperatures? So yeah, now it's running, and now you can see that we're hitting like 75 degrees, because Linpack is very hot. And also right now we're only running 4 gigs, so the load cycling is going to be very, very rapid. So it just blipped like 76, and then it immediately came back down, because, well, 4 gigs of memory, like 4 gigs of data doesn't take that long to process. What's also neat is it does have a performance indicator in the GFlops number, so 440. If that goes up, then obviously performance is increasing. It tends to be very memory limited, so if you're doing memory overclocking, that'll actually blow up the gigaflops number a lot as well. Oh yeah, now we're peaking, according to the package power reading over here, we're peaking over 200 watts. Let's see if that agrees. Yeah, the ISL 69269 actually agrees with that. So yeah, as you can see, Linpack gets very hot. Which is why I like it as a stress test, because it is very, very quick to get upset with any kind of instability. So we can probably go up to like 1.3 volts load voltage on the CPU, considering that right now we're hitting minimums of around 1.17 and hitting like 75 degrees. I hope I can go over 5 gigahertz. Like, I'm not sure. Okay, and there. So Now, this obviously isn't a stress test. This is just a demonstration of how Linpack runs. If you were running like the 6 gigs or the 10 gigs or 14 gigs, which is what I would recommend for a 16 gig memory configuration. And actually, I use 14 gigs also if I'm testing like 32 gig memory setups, just because the 30 gig Linpack, the runtime of each loop increases with the memory usage. So if you're set to like 30 gigs memory usage, it takes forever to complete a loop. And you do need to check if your residuals are all the same. Like, there should be no differences between the residual numbers loop to loop. So, yeah, anyway, also it's worth noting that Linpack is basically the most up-to-date. Like, if you remember OCCT or Intel burn test, Linpack uses basically the same stress test, just like updated for 2019. I think I'm using the 2019 version. There's also a new version for 2020. There's not that much of a difference between the 2019 and 2020 version for like mainstream CPUs. I think it's mostly for the HEDT CPUs with Avx 512 where you'd really see a difference. So anyway, now let's get into actual overclocking, because we did some baseline runs. And that's just like the software I like to use. Then for memory stability testing, well, Linpack actually does a good job of testing memory overclocks because it hits the memory controller really hard. But then, so if I pass Linpack for memory testing, I also run HCI mem test. So anyway, let's get into this. So we're first going to set our base clock to 100. Enhanced multi-core performance is auto. CPU clock ratio. I don't know if we're going to do 5 gigahertz right off the bat, so we're going to start at 4.8. Ring ratio, we're going to start at 4.3 because that's the stock ring ratio, and the thing is, the ring, like, ring ratio, the ring is fed off of the Vcore power rail, as well as VCCIO. And so the thing is, if you raise the ring clock really, really high, really early, you're going to have massive issues passing proper stress tests. Like, Cinebench will run ring clock at incredibly high settings and it'll pass. But if you actually want your memory, like, the ring to be properly stable, you want to probably run something like Linpack or Prime 95 with high memory usage, or something that actually, like, stresses the memory system, which Cinebench really doesn't. Very few workloads do that well. And because the thing is, if your ring is unstable, that's when you get the sort of random, like, oh, my system just shut down for no reason kind of errors, where it's like, there's no warning, there's no blue screen, you don't get anything, it just locks up and dies, and, you know, yeah, so I really strongly recommend you don't max out the ring first thing. It makes your life very difficult. CPU Vcore, we are going to, okay, we're going to set this to, so fixed Vcore is some new thing from Gigabyte that I've not tested yet. So for now, we're just going to work with override because that's what I know how to work with. We're going to start with, yeah, sure, 1.4 volts, which sounds really high, but the thing is, we're going to go to our advanced voltage settings, and here, we're going to go to CPU Vrm settings, and we're going to ignore AC/DC load line, and we're going to set Vcore load line calibration. We're going to start with medium. I want to see like 150, like 150 millivolts worth of V-droop when we're running Linpack. Just because that's actually good for transient response. Vcore protection, we're going to max out. We're going to max out. Current protection, max out. We're not going to touch the VRM switching frequencies. There's no reason to. And yeah, so we're just going to leave all of that alone. And then here, like all of these voltages, you can basically ignore, so we're not going to worry about those. We're going to... Actually, what is our system agent at? Wait, I think it's health status. VCCIO is currently at 1.25. VCCSA is at 1.3. That's actually, those are reasonable settings. They're a little bit, like for 3600 CL14, they are unnecessarily high. But if you don't want to be fighting for stability, like, yeah, sure, there's no issues having them a little bit on the warm side. Like, neither of those rails pulls a lot of power, but so we're just going to set them to 1.3 and 1.25 so they don't randomly change and, like, affect our stability. Also, if you're pushing high ring clock, you're probably going to need somewhere around 1.2 to 1.3 I/O voltage anyway, so once we get to that, we might need it anyway. BCLK adaptive voltage, we're going to disable. We don't need to worry about that. Memory voltage is 1.45 volts. If we go again to PC health status, we can see that. Yeah, it's 1.44 right now. Or on the side, we can see that as well, because the memory kit has a 1.45 volt XMP. And so we're just going to leave everything like that. And now we're just going to go to advanced CPU settings. And we're going to disable turbo limits. I think that's, so that, and this. We're going to leave actually, they might have changed that. That's been it used to be that on like older Gigabyte boards, you'd disable all the turbo stuff as well, and it was fine, but they've changed the names of the settings a bit, so I guess they've changed how that works. Anyway, so I'm pretty happy with how everything is set up right now. And Avx offset we're going to set to 0. Because the thing is, if you actually have an Avx offset, in a lot of scenarios, it'll actually make your stability worse. Because when Intel CPUs change their clock speed dynamically, they cause a really nasty voltage transient that actually causes instability. So we don't actually want the voltage to be doing anything. Well, we don't want the clock to dynamically change mid-workload. Like, we really, like at idle, sure, but if we're actually running something, please don't change. Also, there was one last thing, which I can't remember where they put that, which is the CPU temperature limit. Oh, there, up at the top. So, this is just for stress testing. If you're actually like if you have a system where you regularly run it at very high load, I would recommend that you don't change the setting. But if you don't regularly run your system, like if you're not regularly maxing out all 8 of your cores with a heavy workload, as in something heavier than Cinebench, because Cinebench isn't heavy at all, you don't want to be set to like 105 degrees. But if you're just stress testing, Linpack has a tendency to get really like high peak temperatures. So, and the thing is, if you thermal throttle while running Linpack, that can actually cause the system to crash because of the same reason that the Avx offset causes crashes at random. So, yeah, we want the thermal limit a bit higher. But if I was going for day-to-day usage, you probably should just leave that on auto. Well, if you have a system where it regularly hits, high loads, you should leave that on auto. Actually, we could probably, I don't know, we might run out of voltage headroom before we run out of. Let's leave the temperature limit on auto because it was admittedly just running 75. So, yeah, save that. There's not really much to this. Like, at this point, all I'm probably going to do is maybe bump up the LLC another notch. Because the thing is, well, actually, I might give you a demonstration of why it is that you don't really want to run the maxed out LLC. Also, this capture, well, I should have just used an AMD GPU. That's what I should have done. that would have been infinitely easier. Anyway, so we get our hardware info open. And I think Cinebench is going to score a little bit higher now. Right, so yeah, we're running 4.8. Right now our voltage reading everywhere is absolutely ridiculous. Also, the thing is, now we should actually see a bigger difference between the voltage readings between like the Vcore over there and then of course the VR Vout. So this is the voltage we care about. This right here is just like, doesn't matter. And same goes for the CPU Z voltage reading. We don't actually care about that one. That VR Vout is the only one that's important. So we're going to run our Cinebench. And why is that so high? So we're getting 1.4. Wait, I set it to 1.4. That is like no droop. How's our temperatures? Temperatures are 80s. Did I use the wrong voltage option? I might have used the wrong voltage option. Because, yeah, we're not supposed to, like, this isn't supposed to be flat. And this isn't supposed to be going up. Yay, Gigabyte. Okay, so I need to go fix that, because right now we have way more voltage than what I wanted. Like, I want it to idle at 1.4 volts, and then when we hit full load, it should be dropping down to like 1.3. Or maybe even, well, 1.3 is what I'd want it to do. So, why isn't it doing that? It's set to medium. This is all disabled, so... Yeah, that's all set. Okay, well, let's try fixed. 1.4. And... Because basically what we had right there was like, that looked like it was on maxed out LLC, which I really don't want. Because basically the problem with that is like, yes, your voltage doesn't actually change going between idle and full load, but the thing is you can't actually see the deviations in the voltage caused by the loading of the CPU, because those happen way too fast for any kind of software to pick up on that, and I have a bunch of videos covering that, so you might want to check those out. I'll probably remember to leave a link. If I don't, hopefully somebody like somebody else, somebody who watches the channel for a while will leave a link in the comments. Anyway, so hopefully now the LLC settings are actually doing what I... Yeah, okay, now VRV out is idling below what I set. So if we open up CPU-Z, because I do want to show how CPU-Z is going to be measuring the voltage different from what it's supposed to be measuring. Now we're going to set this over here, and we're just going to run Cinebench, and our voltage should drop a lot. And it's dropping, yeah, about 100 millivolts. So that's basically what I was hoping for. And you'll notice that here we're seeing 1.356 volts. So again, there's that voltage measurement disparity between the CPU socket versus the actual die of the CPU itself, so the silicon. Which this is fine. I think Linpack might be a little bit of upset, but also it depends on what kind of temperatures we're going to hit. The thing is, your CPU's power consumption goes up quadratically with your voltage. So if you increase voltage by 10%, your power consumption goes up 20%. Whereas your frequency to power consumption relationship is linear. So going from 4.8 gigahertz to 5 gigahertz doesn't really change your power consumption very much, because 200 megahertz is, I don't know what percent, it's some smaller percentage of 4.8. And yeah, so we've already got a little bit of a performance uplift in Cinebench just because instead of 4.7, we're running 4.8. Actually, I think that's a bit higher than it should have been for that frequency difference. Yeah, so Cinebench is pretty happy right now, but of course what we mostly care about is Linpack. And I forgot that I have to press yes on that. Or Prime 95, which I also have. Anyway, so we're just going to go stress test 2. We're going to go 2, and we're going to run it 3 times. Yes, yes, no, enter. And let's get... Because I do want to, like, I like watching the memory usage go up so that I know. Because if you're doing a lot of memory overclocking, Linpack will basically, if your memory settings are really unstable, or if your cache is really unstable, so the ring ratio is really unstable, the moment it hits its max memory usage, it has a tendency to insta-crash. So that's one easy way to tell if, like, oh, you screwed up your memory settings. Anyway, what's our CPU temperatures at? CPU temperatures are fine, right? We hit 89 degrees. That's cool for a Linpack stress test. Obviously, if we were running longer workload loops, then the temperature would keep rising because we are on an AIO and, you know, we're nowhere near maxing out the thermal capacity. Minimum voltage on VRV out was 1.269. We might be able to hit 5 gigahertz with that. Depends on the quality of the CPU. And if we can't, we can always bump up the voltage a little bit. It would be cool if we could do 5.1, but I'm really not sure. again, like I've never tested this CPU. So also you can see that our gigaflops number has gone up a little bit, because again, Linpack tends to be kind of memory limited. So I think the highest stable Linpack gigaflops number. Also, the thing is the gigaflops also will scale a bit with your memory usage. So like the higher memory usage tests, because they get higher gigaflops numbers because the relationship between how long it's loading stuff into the memory and how long it's actually running the calculations biases in favor of the calculations the more memory usage you set. So that's another thing is if you're testing like 4 gigs and then you test 6 gigs, you'll notice that there's a performance difference even if you didn't even change the settings. So that's one thing to also keep in mind. Anyway, so everything is, yeah, residuals are all the same. Yep, pass, pass, pass. Temperatures during that were fine. Obviously, if we were running the higher load, then the temperatures might not have been fine, but that's just something you have to deal with when you get to that point, right? So yeah, we were hitting 90 degrees on the hottest core, so that's cool. Because if it thermal throttles, then the stability test is invalid, and the mouse decided to stop working for some reason. So at this point, I'm just gonna bump the CPU straight to 5 gigahertz and see if it insta crashes. So here we are. We're gonna bump our CPU to 5. And actually, I think I might leave it at medium LLC. Because the amount of V-droop we're getting, I'm happy with. And so if I need more stability, I might just raise the voltage. Because the thing is, idling the CPU at like 1.4 plus volts is fine. Also, you'll notice actually, even at idle, we have so much V-droop that 1.4 volts translates into like 1.38. Even when we're just sitting on the desktop. So yeah, I'm really not concerned about the CPU's lifespan with the settings that I'm running right now. Let's run that. If we open Cinebench, no, that's the wrong Cinebench. What? Oh, it's down here. I should put it up there. And of course, Cinebench runs just fine because it is not a stress test. It also runs ice cold, as you can clearly see. Yeah. If we scroll down, you'll notice that the V-droop is a bit higher because the V-droop is actually proportional to the current consumption. So as you increase the clock speed, the current draw goes up. Therefore, the V-droop increases. That's also why Cinebench has less V-droop than Linpack. And that's a good thing, because the more current the CPU is pulling, the more violent the transients can be. And the thing is, you really like the... So there's not really any issue with having a bunch of voltage overshoot. It doesn't really cause a lot of, it's so short that it doesn't degrade the CPU significantly. The problem is if you have a really aggressive LLC setting, your stability goes, you end up having to run significantly more average voltage for the same level of stability, and the end result of that is that you end up with higher CPU temperatures, and the warmer the CPU is, the less stable it is. So yeah, there's really no benefits to having a very flat voltage setting, because you'll just end up with less stability than you actually want. So now we're going to run 2 again. We're going to run 3 loops. Yes, yes, no, enter. And so, again, watching the memory usage as it's starting up. And now it hits 5.2 gigs, and it did an insta-crash. So that's a pretty good sign that this is somewhat runnable. Now our voltage is down at 1.26. What are our temperatures like? Okay, we're now getting up to that 90, low 90s, which still fine. Like, this is Linpack. There's nothing you're going to run that's even remotely this heavy. So, or actually, there might be some things that you run that can get this heavy, but that would be more like scientific compute applications, not really... like if you're playing games all day on your system, then Linpack is extreme compared to anything you'll ever throw at it. Unless you play a game that for some reason has like massive amounts, like some crazy CPU simulation on it or something. Like, there's nothing theoretically stopping a game developer from making a crazy physics engine that runs AVX2 and hogs the CPU resources. It's just that nobody does that because then, like, nobody's system would be able to play the game. Anyway, so the first loop, also it's actually worth noting, like, you can save the residual values, and if you just remember what the correct value looks like, you can immediately know already on the first loop if it's wrong. So yeah, at this point, like, if I wanted to prove that this is stable, I would just set Linpack to run for an hour and I'd call it a day. Also, I'd set it to use 6 gigs of RAM instead of, well, 10 gigs of RAM instead of 4. And then just run it for an hour. And if it passes an hour of Linpack, that's good enough in my book, because there's really very little that you would throw at your system that's as heavy as Linpack. And it does get extremely hot. So, yeah. Anyway, we need to keep going. Like, I need this to crash. I have no idea where this CPU tops out, so I'll be impressed if it doesn't insta-crash at 5.1 in Linpack, but... Well, actually, maybe I won't be. We have a lot of E-droop on this. I might do like a low V-droop versus high V-droop comparison, depending... Well, actually, yeah, I'll do it. Screw it. I don't care how long this video is. I'm going to try to cover as much detail as possible, so I will be doing a demonstration of why you don't want to run super high LLCs. But we first need to get to some settings that are relatively borderline in terms of stability, because otherwise it takes forever. Like I don't want to run settings where it's like I don't know if they're going to crash. So if we get to some settings that are borderline stable, then if you throw like the incorrect LLC on them, then yeah, they're going to be very, very unstable. And at this point, we're just going to skip straight to the Linpack part of the routine, because I don't actually care about the Cinebench performance that much. So we're at 5.1. Now I'm expecting it to actually crash. Where's my task manager? Also, Linpack is really good at stress testing the ring of your CPU as well. So yeah, if we start, we'll do some ring on overclocking as well, because that should actually be quite easy to get Linpack to fail it. Okay, we've hit 5.2 gigs and it didn't instantly lock up. I am actually kind of surprised by that. Because the thing is, like, okay, the CPU is pulling, according to that, it's pulling 300 watts. According to the VRM, it is pulling 257. I trust the VRM, not the other reading. So yeah, 257 watts, that's about right for an 8-core doing 5.1. And we can see that our residual is incorrect. Previously, it was like 5.0667, whatever. Yeah, that's not good. So at this point, we're on settings that are pretty borderline, right? Like, the residual's wrong. So if I now throw, like, and you'll notice our minimum voltages are like 1.26 volts. So if I go into the BIOS and punch in 1.2... I don't know, 1.27, 1.26 volts, right? And set the LLC to extreme, I would expect this to actually insta-lock up, because the VRM will actually be trying to do something that it's physically not capable of doing when it comes to regulating the voltage being supplied to the CPU. Basically, think about, one way to think about this is the CPU is pretty much brake checking the VRM, and if the VRM doesn't manage to brake hard enough, fast enough, then the VRM plows into the CPU and everything crashes, and you get a crash, right? Or if the CPU brakes check, or if you have it set wrong in the other direction, you can end up where, like, the CPU's brake checking the VRM, and the VRM ends up lagging behind the CPU significantly. So yeah, so this is one downside. Like, there's apparently a run like option to get Linpack to do these checks for you, because it says pass right there, but we can see that the residuals are different. But so there's an option to make it check that the residuals are the same between loops. But I can't remember how to set that, so I just manually, like, I just look at it and go like, well, they're not the same, so this is unstable. So this right here is not passed. So this is already unstable at this point, which doesn't surprise me. We're at 5.1 gigahertz. We're feeding the CPU very little voltage. So now, I mean, we can try stabilize that. I'm going to bump up the thermal limit. Obviously, if we had a bigger cooling system on the CPU, that would be great. This is just a 240 millimeter AIO, so what we're going to do is I am going to go CPU over temperature. Because I want it to be, like, I want it to pass the 3 loops, and then we're going to do the LLC thing. So I'm going to set it to 105. We're going to bump it up by 20 millivolts, which I'd expect that to be enough. Hopefully it doesn't get too hot. The main thing with a bigger loop, like for right now, the 240 is doing a good job because the load isn't very long. But if we were running the higher memory usage Linpack settings like 10 gig, 14 gig, that kind of thing, then the AIO would not be keeping up. And in that scenario, a bigger water cool, like a custom loop would be great. Custom loops can, because the thing is the big advantage with custom loops is you can build loops that will maintain the water to air temperature delta down to like 10 degrees or something, or even 5 if you go really overkill on how many radiators you have. And I plugged in the HDMI cable wrong. There we go. Yeah, sorry about that. I know that it's really annoying, but it's just like NVIDIA GPUs and my capture card hates each other, and there's nothing... Like, I don't, unfortunately, have any passive AMD GPUs to use for this kind of testing. No, I didn't want to do that. Okay, so now I'm actually very interested in our CPU temperatures. The voltage is fine, right? Like, previously we're drooping down to, like, 1.26 or whatever, so we have voltage headroom if we needed it, but... Thermally, I think we're limited at this point, so we're going to be watching the temperatures, and we're going to set it to run 3 loops, and yes, yes, no, start. So now I'd assume the residuals will all be the same, and then we're going to look at our minimum voltages, and we're going to set, you know, a flatter LLC. Like, I'm not actually sure how the transient response is on this motherboard, but honestly, we could probably set like 1.29 with a flat load line, where it would just constantly read 1.29, and I'd expect it to still crash Linpack, or at least spit out calculation errors. And now our temperatures, we're still holding 90s. That's actually okay. Now 20 millivolts is not that much of a voltage difference, and yeah, see, so that is the result that we were looking for, so that is correct. So hopefully the next 3 loops will also be correct. Now we're getting 470 gigaflops, so nice little speed increase. And oh no, what did I do? It'll come back. Like when it prints the next result, it'll come back, I think. Right? Yeah, so now it hit 94, so we need a bigger cooling system at this point. Also, liquid metal on the IHS wouldn't be a bad idea. The CPU's pulling over 260 watts at this point, so it is producing a hell of a lot of heat, and it's not like the IHS is that big. If you had a 10600K, then obviously you would still have voltage headroom left over because you have less cores, and less cores means less heat. So now we're hitting 96, which is why I raised the temperature limit, because if it started thermal throttling, then this would throw off the stability test. Also, where are my results? Oh, there we go. Yeah, so these are both correct now. So maybe 10 millivolts less would have also worked. Why does it keep... There we go. So now it passed. So there. So we just stabilized that. So I didn't actually get the blue screen that I asked for. If we bump it up to 5.2, the thing is the voltage requirements on CPUs generally aren't very linear, so going from 5.1 to 5.2 should need a significantly larger voltage increase, so I'd expect 5.2 to just insta-crash, but let's do the LLC thing. Let's set the LLC to an appropriate setting. So if we look at our VRV out, so right now we're at idle 1.4 volts, which is fine. Idling at 1.4, like, yeah, your idle power consumption's kind of high, but it's a desktop. It's not like you're trying to save battery power. Also, I live in the UK. It's pretty cold most of the year around, so, you know, I can do with the extra heating. I guess if you have AC on in the summer, then, yeah, a couple watts of idle is actually might be a pretty big concern. So, yeah, 270 watts going into the CPU on the Vcore. That's not including, like, VCCSA and the various I/O rails, which actually, well... Does this board not have that? Oh, whatever. So, okay, so 1.28 volts load voltage. So, what if instead of, because right now we're idling 1.4 and then, it droops down to 1.28. So now you might be thinking, but why can't you just set it to 1.28 and pass 5.1 gigahertz? Well, let's do that, shall we? And the mouse decided to stop working again. USB device not recognized. Thank you, Windows. Just shut it down manually. Power it on again. I said power on. There we go. So now I'll set the core voltage to 1.29 volts, and I'll set the LLC to ultra extreme. I think the board has the setting, so we're going to go 1.29. Which is still a little bit more than it was going down to, right? And now we're going to go to CPU Vrm settings, and we're going to go to Ultra Extreme, which should give us a very nice flat load line. So we're first going to check that in Cinebench, because I expect Linpack to just insta-crash. Yeah, there's also Prime 95 128K FFT size. That'll also insta-crash. Like, that should also insta-crash. Though I'm not sure. Like, Linpack, as far as I know, might be heavier than Prime 95. So at this point, I'm not really sure that one, like, Prime 95 would complain. It might, but we were testing Linpack, so we're going to use Linpack again. So now if we open up hardware info and Cinebench and all the things... So yeah, so we've got Cinebench. We're going to use Cinebench to check that the voltage isn't drooping, right? So previously, if we ran Cinebench, we'd go from like 1.4 volts down to like 1.3. And so now we're set to 1.2, right? We're reading 1.288. And now if we run the workload, we're going to hopefully not crash. No, it's running. And still 1.28. So you'd think, like, previously we were getting a minimum voltage of 1.28 volts, right? So this has to be stable, would be the incorrect assumption. And now I'm going to be proven wrong, as it doesn't insta-crash, but... Anyway, so Cinebench, obviously not very upset with it, because Cinebench, Cinebench on an oscilloscope looks like silence. Like, there is very little going on, so... Let's do 2, 3... And... Yes, yes, no. Please crash. Otherwise, I'll have to switch to Prime 95. Okay, 4 gigs, 5.2. I can hear coil whine now. It's not crashing, though. That's disappointing. Yeah, it's not crashing, so... And that is correct. Damn it. I should have used Prime 95. No, that's still correct. I have to say, I'm surprised. I was totally expecting this to not work. Okay, well, we can try it the other way around. We can run Prime 95 now and then go back to the 1.42 volts medium LLC and see if that, well, assuming it even crashes with these settings, right? That's kind of the annoying thing right now, is like, wait a minute, this ain't crashing. Why isn't it crashing? Where is Prime 95? So this is Avx Prime 95, and we're going to go small FFTs and then 128K. The reason why I set it to 1 at 28K is this is a very stressful FFT size in my experience. So how's their temperatures? Is this the wrong version of Prime 95? Or did the cache size change for these CPUs? Wait, I used an 8700K last time I did this, so... Oh, those are 12 megabyte. Okay, so this is probably too small. Oh, there we go. Well, that would be a memory error, though. That's not the error I was hoping for. So that's a bit of a problem. So I'm very surprised, because if you did something like this on Z390, it would be such a drastic difference to stability. Anyway, we're going to go back to medium. Alright, I want to check something, because the mouse moved and it went to no. So, okay. Wait, seriously? There's 16 megabytes of L3 on these? Oh, there is. Cool. So I probably need a slightly higher FFT size. Still, though, I'm disappointed in Linpack. It was supposed to be, like... Okay, no, we need to use, like, 192, I think. Okay, so 5.1. CPU temperatures are even colder. Well, yeah, that's what I expected. Well, now the average voltage is like 1.33. I need scope shots. Because the thing is like Gigabyte put like probably put a lot of work into improving the transient response on their Z490 motherboard designs compared to the Z390s. So I might be, like, my expectations are based on the Z390 boards. And if what I just did would have, like, should have been a problem. So I'm very surprised that it isn't. No, main thread. No, so yeah, this isn't gonna work. Okay, well, let's try 5.2. Though, admittedly, Ultra Extreme did have coil line, which is interesting. Not that, like, that's a sign of anything significant. It's just like, yeah, there was a bit of coil lines. So, try 5.2. The thing is, there's no temperature difference. And I guess it means that, you know, instead of medium, you could maybe use turbo or something for your LLC setting. I still wouldn't use a Ultra Extreme just because I don't trust it. Like, it shouldn't be good. I don't know why it didn't insta-crash. It might have been that I didn't run it for long enough, because that's the other thing with stability, is sometimes you just need to run the stress test a bit longer, and then eventually the issues start showing up. Actually, let's try Prime 95 again. I'll try... The thing is, I'm not sure what FFT size is necessary for 16 megabyte L3 cache CPUs. Because the transient response is kind of... Oh, there we go. IRQL not less or equal instantly. Great. Also, if I was going for like full stability with Prime 95, I'd be running from like 32K FFT size all the way up to like 512K FFT size. So that it just hops between the different FFT sizes. Oh, damn it. I did it. Is the reset button? Oh, there we go. Reset worked. I was holding the power button and it wasn't doing anything, so that was weird. Okay, so... Thing is, Linpack was already hitting like sort of the limits in terms of temperature, so... I'd call 5.1 good enough, and I guess, yeah, so we'll just leave it at 5.1 at this point. And let's start working up the cache. Let's try 4.5. So I guess, like, so from my very quick test here, I guess you might be able to get away with different LLC, like higher LLC settings. And slightly less set voltage. And now the capture card works. This is so weird. Anyway. Unpack, hardware info. Thing is, apparently, like, from what I've heard, apparently the cache is more sensitive to transients than the cores are. So maybe once I bring up the cache, then we can switch to the, like, ultra extreme, very low voltage configuration, and it'll start crashing again. The thing is, it might start crashing right now just because as you increase the cache speed, Linpack is probably going to increase in gigaflops, and as the gigaflop, like the more work Linpack is able to do, the more load it puts on the CPU, therefore the less stable the whole thing is going to be. We're going to go 3, yes, yes, no, and let me just check that we're scrolled down to the correct part. Yes, we are. Fire it off. There's also a chance that Gigabyte's VRM is just absolutely incredible. So, which is kind of the main reason I bought the 10700K is like, I really, really want to get some oscilloscope measurements of the various Z490 boards because like Gigabyte and also Asus actually have made some drastic changes to their capacitor configuration in the CPU socket. So that calculation is correct. Yeah, but the gigaflops actually didn't change, so that's neat. So I guess we're not, like, the thing is the cache connects the, like, the cache/ring ratio connects the memory to the CPU, so, if your memory bandwidth starved, then Linpack isn't going to increase in gigaflops just because you raise the, like, if you raise the cache ratio but your memory starved, then it's not going to do anything in Linpack. There are other workloads which will be potentially cache starved, so that's also fine. Okay, also correct. Scroll back up to our temperatures. How are the temperatures doing? We're doing fine, 93 degrees. Yeah, I see absolutely no issues with that. I mean, admittedly, this is a really short test, but you can always get a bigger heatsink. Well, that would be a cache crash. Probably. There's also a small chance that there's some weird driver issue with this Windows install at this point. The thing is, like, unfortunately, cache errors are really sort of random in terms of their symptoms. Like, sometimes you get the system black screens and just dies out of nowhere. Sometimes you get a blue screen. Sometimes Linpack starts spitting out errors. Sometimes it spits out errors and then crashes, and sometimes it just spits out errors and completes the run anyway. There's no real, like, oh, this is definitely a cache problem. It's kind of like, all of these can be cache problems. Anyway, now I want to try the LLC thing again. 1.29. Because that was, obviously that was having some kind of stability problem. So let's see if we can make it worse. But at this point, I'm already pretty confident in calling this a 5.1 gigahertz CPU. Like, definitely if you fiddle around with the voltages and the settings for long enough, 5.1 is possible on this chip, which is good. Like, the CPU has a max single core turbo of 5, so we have more single, or is it max? Oh, max turbo boost frequency, but that's for thermal velocity boost. So, yeah, okay. So for thermal velocity boost, it has 5.1, but regular turbo, it has 5. So we have more single core. We have the same single core performance as thermal velocity boost, and we have quite a bit more multi-core as well across all workloads, regardless of how heavy they are. So let's try Linpack now. 2, 2, 3... Yes, yes. What? No. Enter. Yes, yes. No. Open this. Thing is, I've not actually, like, seen Linpack under an oscilloscope yet, so I'm not sure how it behaves. Like, I've heard it's apparently, like, from somebody else who unfortunately doesn't have an oscilloscope, I've heard it's better than Prime 95, but, though we'll see. That's correct. Oh, there we go. So it crashed in one loop instead of two. That's not a great standard. The thing is, like, there's also a temperature. Like, unfortunately, stability is a combination of, like, temperature, voltage, and frequency settings. So if you run a stress test for longer and you end up at a higher temperature, like, that'll actually change the stability parameter, like, the stability as well. So, yeah, it is really unreliable to try test for something like this without... Well, like, I'll eventually get oscilloscope measurements, but ultimately, I probably wouldn't use Ultra Extreme or Extreme LLC. Turbo might be viable, based on the fact that Ultra Extreme doesn't seem to be massively... Like, I was really expecting Ultra Extreme to just die instantly, which it didn't do. So that's actually kind of impressive. Yeah. For... day-to-day overclocking, I still wouldn't run it. Anyway, so let's go back up to, like, 4.2. I guess we could go for, like, 4. Well, actually, I don't think we need 1.38. No, 1.38, and I think, the thing is, like, cache errors can show up as all kinds of various random, like, driver IRQL not lesser equal is, like, that's potentially a memory error. It's also a cache error, like, because the cache is part of the memory system. So if you have cache errors, they look like RAM errors. I hate ring overclocking really a lot. Like, it's really, really hard to diagnose what kind of instability issues you're having with it. Now, the thing is like your average voltage, the VR Vout reading is what actually sets your sort of thermal performance. So, Actually, you know what? Let's try 1 point... Like, I want to just do another check that 1.42 was actually unstable. Like, that it's going to crash again. So I'm going to run 4 loops this time just to hit it a little bit harder to see if it really is the cache complaining about something. The thing is, there's also a bit of a, like, a sweet spot effect with the I/O voltage. So maybe shifting the I/O voltage up or down a bit might help. Though I think for 4.5, I probably have to shift it up. You can, like, you normally need kind of a lot of I/O voltage. So, yeah, we'll see. Maybe it's just an I/O voltage issue, but if changing the, like, massively raising the I/O voltage doesn't fix it, then, I don't know what setting I just selected to 4 loops. Yes, 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 no, enter. The thing is, like, it could be a Vcore thing. Unfortunately, because both voltages affect uncore stability, you're just kind of screwed on when it's like, oh, I wonder if it's too little I/O or if it's too little Vcore, and it's like, well, it could be both. And if it's both at the same time, then changing one of them isn't going to tell you which one it is, because you're still going to crash. So on my 10900K, I was limited to, I think, 4.4 stable. For the Encore, or maybe actually no, I think I'd managed 4.5, but with like 1.3 I/O volts. I was kind of hoping with an 8-core CPU, because the ring has to handle less cores, it would be, you know, it would clock a little higher, but I might be wrong. Like, it looks like I'm wrong about that. We still have plenty of I/O voltage headroom, though. We can go all the way up to like 1.4 volts I/O. Though, admittedly, like 1.4 volts I/O voltage, in my opinion, is like you're being that's the absolute limit. Like, I wouldn't go 5 millivolts above that. Ideally, I'd want to stay closer to 1.35 than to 1.4. But 1.4, if you need it, yeah, that's still relatively safe. And now it's not going to crash, is it? Yeah, this is the thing, is like the like crashes sometimes are just like, the crashes can be kind of random, so it's really hard to like do quick demonstrations of like more like temperature sensitive effects and that kind of thing. So yeah. Anyway, so now we're hitting 97 degrees. I guess the AIO is getting kind of quite warm. And it managed to do all of those without any errors. So I guess, well, let's keep trying to raise the cache higher. The thing is, there was like that blue screen earlier, but, you know, like, unless you were like this is the advantage you would have that I don't. If you were running 10 gigs of memory usage instead of 4, and running like 30 minutes instead of trying to quickly cram all of your stress testing into a video, or actually, like, if I'm just doing like iterative testing, I would test like 20 minutes, and then when I feel like it's pretty stable, that's when I would go to the like 30 hour, well, ideally an hour, right? Like, an hour isn't that long. I would run Linpack for an hour. Some people are insane and they'll run their stress tests overnight. I think that's completely unnecessary. Hey, if you want to go do that, knock yourself out. Like, it's your CPU, not mine. I run memory tests overnight, but Linpack is not exactly something like, it pulls a lot of power. So it's just kind of like, yeah, I'm not gonna run that long. And the capture card's really annoying with that. Also, the glitching that like I get after unplugging it and plugging it back in. I'm gonna run 3 loops, because I'm not sure if we'll be able to run 4.8. We'll see. We're not going to do any memory overclocking. I might do a memory overclocking video with this setup in a part 2. Did I forget to press enter? I did. Where is the VRV out reading? Where'd it go? Oh, there it is. And, oh no, it's still running. Okay, yeah, that's incorrect. So now we have cache stability issues. Because it's the last thing we raised was the cache, and I guess there might be a chance that this also has some kind of driver problem on this system. Because it also, like, blue screened at 4.5, which is really early. Okay, well, that loop is correct, but the first one isn't, so, like, it's still unstable. In terms of temperatures, 96, that's fine. Like, the thing is, the temperature isn't really going to change that much. The cache clock, as far as I'm aware, like, the cache clock has even less of an effect on your CPU temperature than your core clock does. So, yeah, this was wrong, because, this one's wrong. So at this point, we already know the cache is unstable. But I wonder if we can make it more unstable. I still want to do the LLC thing. Like, this is the, like, I really wish there was some way that motherboards could actually tell you your, like, minimum voltages, for, like, sub 1 microsecond minimum voltage. But, yeah, there really isn't actually. Why am I doing that way? Be civilized. Type your voltage in. Anyway, let's get to VRM settings. Ultra extreme. So now I'm hoping it'll either make errors on all 3 loops or it just blue screens. One of the two. That's what I'm hoping for. So probably the CPU might be the funny thing is like you can boot like with my 10900K, for example, I can run benchmarks all the way up to like 5 gigahertz cache. And then when I want to stress test it with Linpack, I can't go above 4.5. So, you know, it's just like, just because, oh, it just did it. Oh, it just locked up. Yeah. I think it locked up. Like, we didn't even do anything and it locked up. So I'm going to try again. So now I'm hoping that I'm actually getting the effect I was going for, which is like the cache is really upset with the LLC setting. Which it could be. Like, again, like from what I've heard, I've not actually tested this myself. I normally focus on core clock because core clock generally has a far greater impact on your overall performance than cache clock does. But, okay, mouse works now. Yeah, like there's a good chance that, well, I've heard that the cache is more sensitive to having the LLC set too high. Oh, and it died again. Yeah, it just, like, see, we can't even freaking start Linpack. I wonder, like, oh, and reset button's dead. Yeah, like, reset button not working tends to indicate that the cache died. That still works, though. So I think at this point the cache is very, very upset with us. Because it's more sensitive than the core to transient response. That's a nice thing. So I guess you can test your LLC settings by like messing around with cache clock and seeing how unstable it gets. So we'll try 4.7, but I expect it to just puke errors everywhere. Maybe we'll even get a blue screen. Maybe we'll be able to start Linpack for once. Or we might get the whole like, oh, it gets up to 5.2 gigs memory usage insta crash. Any of those is completely fine with me. And also, if you're crashing regularly, you'll eventually get like, please wait, like this error screen from Windows. Or you just say restart. Also, it's worth noting that if you don't want to like, so I'm primarily, well, I still prefer Windows 7. Mostly because it's far more robust than Windows 10. Like, I've never corrupted a Windows 7 install. I've destroyed Windows 7 installs by trying to, like, remove various parts of them when trying to optimize them for benchmarks. But I've never corrupted one with, like, unstable overclocks. Windows 10, on the other hand, I've done that occasionally, where it's like I'll be overclocking, especially memory overclocking. Like I've had that actually corrupt Windows 10 installs. So if you don't want to like lose all your data, I would strongly recommend that you create like a second OS partition on your hard drive or on your SSD or whatever, or you just get like a really cheap secondhand SSD for like 20 quid or whatever, or $20 if you're in the US. And you throw a Windows install on that, and you use that one exclusively for stress testing so that you don't break your daily operating system, because that can suck a lot, right? So, yeah. Anyway, let's see if we can run Linpack now. So previously, it wasn't even able to open Linpack. Okay, I pressed the wrong button. 2, 3, yes, no, enter. So, I mean, I guess it's a good enough demonstration with the whole, I set 1.29, I max out the LLC, and oh, look, I can't even freaking open applications anymore. Though, admittedly, the idle voltage for 1.42 volts was much higher. Right, because the LLC isn't drooping us down at idle. Well, that one's correct. That one's also correct? Damn. I have to say I'm surprised by that. Yeah, okay. I really need to... I can't wait to hook up the oscilloscope to this board. Because, like, on Z390, I would expect doing this to just instantly not... Like, this shouldn't work. How is this working? Man, this is insane. So I guess maybe Ultra Extreme LLC isn't a complete disaster. I mean, I hate to say that, but, like, yeah, like, admittedly, like, keep in mind our temperatures aren't any better. Like, now it's hitting 98 degrees. Yeah, so at this point, you would, like, actually just run your stress test for much, much longer than what I'm doing here, but I want to see the Cinebench performance. So, with just the XMP profile enabled and stock settings, it was doing, like, 4771, so 4771, and, or around 4700, so now we'll see what it spits out. I'm impressed though. Like I was really expecting Ultra Extreme LLC to be like drastically less stable than the like high idle voltage medium LLC combination, but maybe whacking all those tantalums in the socket actually made, like I still like the thing is I messed around with that kind of a thing on Z390 and it was like nothing I did made any of the boards like massively better in terms of transient response. And then it's just like, oh yeah, but well, I guess if you implement like if you design the entire motherboard about how around having different capacitors in the socket, then it works better. Yeah, so now we're getting 5333. So yeah, nice little performance uplift, right? 5.1 gigahertz, 4.7 cache. There's a chance that the cache could go even higher, but I think like at this point it might be Vcore limited, right? Because at 4.8, like idle was completely unstable. So um, yeah, but there's like I'll try one last combination of settings. I, you know what? Maybe instead of Ultra Extreme, you should use Extreme LLC. Um, because like I still don't trust it. Ultra Extreme LLC should not work very well. Then again, like Gigabyte did. I did see from somebody who works at Gigabyte that the new fixed Vcore mode is supposed to give like they've done some special optimizations with the fixed Vcore mode, or I think it was fixed Vcore, or maybe it's override. I'm not sure, but one of like they did something with one of the Vcore like core voltage modes, that is like apparently really great for transient response. So yeah, I really need to hook up the scope to this. So anyway, we're going to go up to 4.8, which previously was completely like unusable. And let's see if with 1.3 volts IO it gets any better. I'll be very surprised if it does, but who knows, it might. All right, capture card. Okay, Linpack, hardware info. Yeah, it seems to be a bit better now, isn't it? It's not insta-crashing anymore. We scroll down to VRV out. Okay, I'm gonna go 2, 3 loops. Yes, yes, no, start. And of course, go. Oh, so it looks like it just needed some extra VCCIO. We might be able to go even higher if we just keep raising IO voltage. Like maybe another 50 millivolts would give us another 100, 200. Well, actually, I've not tried 4.9, so we need to try that. The thing is, it's also worth noting that once you overclock your memory, it can easily destabilize any IO overclock that you have. Oh, no. Okay, well, it's not crashing, but that is not correct. So, okay, so maybe even more IO voltage. So I'd say 4.8 is probably about the limit, considering that like we're already spitting out errors. The thing is, we can't really like again the ring slash uncore slash cache scales with core voltage. The thing is, we can't raise the core voltage. The CPU's hitting almost 100 degrees at this point, unless I got a bigger cooling system, which I don't think would even help because we're running a really like 4 gigs of Linpack is not the heavy version of Linpack. It's like the lazy I'm doing quick testing version of Linpack, but maybe a little. Let's wait for loop 3. It looks like this might be possible if I keep bumping up IO voltage. Maybe I should fiddle with the LLC again. Okay, now I did 2 loops, so... And then it locked up. Lovely! Yeah, it just locked up again. So it is very dead. And I'm going to show you that the reset button... Well, I think the reset button doesn't work right now, but we'll test that. So here's the reset button. Yep, that doesn't do anything. So that's a cache crash. So I guess we need to raise the I/O. So this is like the thing is like after when Linpack ends, I assume that like when a workload ends, you get a transient, a pretty nasty one. So that potentially is why it crashed right after it finished all of the calculations. So that's kind of the this is the thing is like stability testing. If you're doing very short stability tests, it's really hard to judge how stable something is because there are certain, like a lot of effects are sort of, you know, somewhat time related. And so, yeah, it's hard to go like, oh yeah, now it's unstable. And actually, I realized that I should probably have the reset button somewhat visible. Anyway, 1.3. Well, we could go back up to that 1.42 setting with medium LLC. Because the thing is, I don't want to figure out what's equivalent to 1.42 medium with a different LLC setting. And actually, I think we could bump up the voltage a little bit because 1.29 Ultra Extreme was running warmer, though the room might be getting warmer. Like I started, like it's the morning. The room warms up as we approach noon, so there's a small chance the temperatures are going up just because of that. Also, the AIO just dumping heat into the room. Well, the CPU dumping heat into the room through the AIO, but you get the idea. Anyway, so we could bump up the medium setting voltage a little bit, just to, because it wasn't running as hot, right? Which tells us that the actual average load voltage was slightly lower because the temperatures are lower. And then let's bump up the VCCIO to like 1.32. And nah, screw it, 1.35. There's no reason to not raise it a lot. Like IO doesn't pull any power, it's not gonna get very hot. Actually, I want to try 4.9. Like 4.9 cache would be ridiculous, but and I assume it would stop working as soon as we start overclocking the memory. But yeah, that's kind of the downside, isn't it? That's still like 3600 CL14 XMP with 4.9 cache, 5.1 CPU. That's going to be fast. That's going to be really fast. No, that's not what I wanted to do. No, what did I do? There we go. You can tell I don't use Windows 10 that much. Because I had no idea that that was like a thing. And if you double click the bottom edge, that it like blows up like that. Anyway, 1 point. There's our VRV out. We're gonna go 2, 2, 3, yes, yes, no, enter. Okay, so we're at 4.9 ring. If it's stable, I'll be very surprised, to be completely honest. Or impressed. Like, surprised and impressed. You know what? I should probably stretch Task Manager so that it's more... I can see more... it's not stable. That calculation is incorrect. But I wonder how unstable it is, because it's possible to get all 3 loops incorrect, which we haven't seen so far. Like, you can actually run Linpack and have every single result be different, which is just kind of like, that's an achievement that it hasn't crashed. This one's also wrong. Like, I've had some runs where it's like, half the results are wrong, like, on like 20 loops, half of them are a different value than they should be, and it's just like, that's impressive that it didn't manage the blue screen considering how many errors it was making. Okay, Linpack finished because we just saw the memory usage drop in Task Manager, so it should print out the last result, and the last result is actually correct, but the other two aren't, so yay. Okay. I don't think more I/O voltage will do anything. How are the temperatures? So now we're hitting 97, whereas previously I think with the Ultra Extreme LLC it was doing like 98, I think. So yeah, the voltages are roughly equivalent. The load voltages are. Anyway, it didn't insta-crash right after it finished all the loops. And we're also at 4.9 cache instead of just 4.8, whereas previously it was crashing at 4.8. Admittedly after it finished the test, but... And again, like, one crash is not a reliable way of saying, like, oh yeah, this is definitely way less stable, but... It wasn't stable, that's for sure. This also wasn't stable, but let's see if even more I/O voltage does anything for that. I kind of doubt it. So I wasn't expecting this video to be 2 hours long, but if it ends up being 2 hours long, that's completely cool with me. Because if anybody asks me, like, Buildzoid, help me overclock my CPU, and I have a Gigabyte motherboard, I'm sending them this, and they can watch it at 2x speed. Would be better than me spending an hour sitting with them, you know, telling them how to change settings. And yeah, use medium LLC or turbo. Like, don't use ultra extreme. Like, I still wouldn't use ultra extreme. I'm not convinced by the fact that it didn't just, like... The fact that it didn't do exactly what I wanted it to do doesn't mean it isn't bad. It just means it's performing a lot better than I expected. Again, like, you know, new CPU, new platform, like, I don't know what to expect. Like, I've done demonstrations of, like, oh, you change the LLC and then you get blue, like, you set the LLC wrong, but your voltage readings are still the same, and then you start getting blue screens. Like, I've done demonstrations of that, but it's like, those are very finely tuned to work. So it's kind of hard to do that when I'm flying blind, where it's like, oh, I have no idea what the VRM's actually doing. I can't see that. Well, let's fire this off. So now we're at 1.4 volts on the I/O. It's not going to do anything to the temperatures. Because, again, like, the I/O rail is... so, like, Vcore, we're pushing hundreds of amps. The I/O rail at stock settings, like, Intel spec for the I/O is, like, 6 amps, which is nothing. So even if you increase the voltage by 50%, you're going to get a 50% increase in current draw, which is going to be 9 amps. Oh my god, so many amps. Right, like, it's nothing. In the grand scheme of your CPU's overall power consumption, going from 6 amps to 9 amps isn't noteworthy at all. Oh my god, it actually didn't make an error this time? That is surprising. First loop is correct. So maybe with 1.4 volts I/O voltage, and again, these specific memory settings, if we make the memory go faster, I am certain that it would instantly destabilize the ring. Which is very annoying, but like that is something you need to consider. Anyway, core voltages are, yeah, 1.283. Arguably, it might be possible to dial this in with like turbo LLC or high or... Oh, damn it. Screwed up. I closed hardware info. Second loop is also correct. So, yeah, so you can kind of see how just raising the I/O voltage fixes the stability. And I guess we're going to try Ultra Extreme LLC one more time now that the cache seems to be basically absolutely maxed out. So how's the temperatures? Oh, wait, now we lost all the temperature data. Well, no, it's still hitting like 96 on loop 3. And actually it managed all three of them correct this time. I want to run 3 more loops. Or, you know what, 4 more loops. One, to check the temperatures. 2, to see if it really is that stable. Like, again, ideally we'd be running more memory usage, longer, like an hour, instead of, what is this, a couple seconds. Like, yeah, it's like 45 seconds of Linpack, which doesn't count. It's not 45, it's like 48 or something, but it's less than a minute worth of Linpack. It's just like, no, that's not a stability test. That's Like, you can use that for getting a rough idea of, like, is it super, super unstable, or is it just kind of unstable? But you can't use it for, like, oh yeah, my system did 5 minutes of Linpack. I'm gonna go do my stuff now. Okay, so it managed to not screw up that loop. 96 degrees. Temperatures are fine. Calculations are correct. Gigaflops are as high as they've ever been. So yeah, I definitely consider this, at this point, a 5.1 Linpack CPU. With reasonable voltage as well. Like, it's not like we're mashing tons and tons of Vcore into it, and you might be like, but BuildZoid, you have 1.42 volts in the BIOS. This is why the cache is annoying. See? It didn't make any errors, and then it suddenly just blue screens the system. Who doesn't love Uncore? Anyway, so we'll call that, like, it managed to do 5 loops without errors. Let's try less volts, more LLC, right? Like, because again, I'm not letting that go until I get the results I want. You might be like, BuildZoid, that's not very scientific method, and it's like, I don't care. Right? Because you shouldn't just be tweaking the test parameters until you get the results that you want, but... Well, the thing is, if you're testing for transient response, then actually you kind of need to. Because if you test the wrong workload, you're just going to see a straight line no matter what you do. So anyway, it would be kind of funny if it got so unstable that we can't even go to the desktop. I would really appreciate if it did that, but somehow I doubt that's going to happen. We're going to go straight to Ultra Extreme. So previously it was running like 96, 97 degrees. Now I'll be surprised if we can even start Linpack. I should stop saying that, because it's been managing to start Linpack over and over again. Alright, capture card. There we go. I'm going to wear out that... And it's gone. It's gone again. It's gone. It just died. You want to bet the reset button doesn't work? Oh yeah. Yeah, that doesn't work. Reset button's gone again too. Yep. So that's why you don't use Ultra Extreme LLC. It went from actually kind of stable in Linpack to literally can't even open the damn program. Well, I mean, it opened it, but then it crashed right after, so that's really not great. And you know what? Let's do it twice. Let's prove it, right? Let's just go into Windows. I said go into Windows. It's a shame that we haven't got like a motherboard vendor who would integrate Linpack into their BIOS as a stress test in the BIOS. That would be kind of neat. Unfortunately, I don't think you'd have access to all the like super accurate voltage sensors, so that would kind of suck, but... Well, actually, they could implement that as well, I think. Right, let's... Okay, mouse works. Let's just open hardware info, right? Like, it can't possibly be as bad as Linpack. Okay, hardware info opened. Cool. Task manager opened. Linpack. Oh. Oh, no. Man, what does Linpack do when it loads up? Oh, it probably has to initialize some AVX thing. And it locks up when it does that. Like, it probably runs, like, a couple AVX instructions and it just dies. Yep, that's a cache crash. Gonna power down. So yeah, this is how you overclock Intel CPUs on Gigabyte motherboards. There's not much more to it. So I'm going to go back down to 1.42 volts. Because again, like, yeah, Cache is very upset at this point about something. Probably the Ultra Extreme LLC, which we can prove by going down to medium. You know, arguably high would work fine. I think for high, we should be running like 1.38 to get the correct amount of droop. I think. I'm not 100% certain. But, yeah, we'll try it. The thing is, like, I'm kind of worried it might get a little bit too hot. Like, if I get the voltage a bit too high, then it'll get too hot. If I get it too low, then it'll crash. And then just mirrors this loading longer than it's supposed to be. Oh no, there it goes. Oh, and for now the capture card decided to work again. Amazing. I hate this stuff. I really do. It's like, why can't you just work all the time? Why is it random? Oh, yeah, and now we can open Linpack, right? Which is great. I can't believe though that it literally won't even open. Like I thought it would be more like you can open it but you can't run it. But then it's like no, you can't even open it. That's impressive. Okay, so 1.36. So I think I might have nailed it with the voltage. And we're gonna do 4 loops because this is gonna be the last run of this video. Like I'm done with this at this point because this is all there really is to it. Like, you know, set the appropriate LLC, which I'd say somewhere between medium and turbo. Don't go above like 1.45 volts set voltage. Like that, like I had that all the way up to 1.42. I still had like 30 millivolts worth of headroom. I'd consider that fine. Because again, like if I punched in 1.45 with medium LLC, I'd be sitting at like 1.43 idle, which is fine. Like that's not going to destroy the CPU. And then at full load, I'd be looking at like somewhere around 1.3-ish. So yeah, and now we're getting 1.263 minimum voltage. So I actually I missed it. I set the high LLC a little bit too low. But it's running stable. Like that first calculation's correct. So I gotta say I'm impressed by that. Temperatures are amazing. I mean, it's at 92 degrees because it's down 20 millivolts. So yeah, I screwed up. It's 20 millivolts lower than it's supposed to be. The CPU is pulling 260 watts. Yeah, it's pulling a bit less power, but it's actually running relatively, like it's done another loop correctly. Again, this is not a full stress test. We're running like freaking a minute of Linpack here. This doesn't count. But at this point, I would go and just run it for an hour. And if it didn't pass that, then I'd probably just back off the ratios a bit. Like I'd back off the ring ratio a little bit. I'd maybe bump up the Vcore a little bit, assuming I still had thermal headroom, which we might not have. This is a 240. It's not that big. It screwed that one up. So yeah, this one's wrong. That loop is incorrect. But I would have been very surprised if it didn't make at least one error. But admittedly, like the Vcore is a bit lower this time around than it's supposed to be. The thing is, actually, if you set your LLC unnecessarily droopy, it can also cause issues because the VRM starts overreacting to, like, again, back to that brake checking analogy I had ages and ages ago. Like it's kind of like if the car in front of you starts braking and you just like come to a standstill and then decide to speed up. So that can also cause issues. Anyway. So that can actually make the stability worse as well. But yeah, so somewhere between turbo and medium. Depends, like, honestly, I would probably set the voltage to, like, I'd start with, like, well, it depends on your cooling system, right? Like, if you have a weaker cooling system, I want a 240 millimeter AIO. So maybe instead of, like, doing what I did where I went straight to 1.4 volts and medium LLC, you should maybe start with, like, 1.35 volts and medium LLC. I would still start with the medium LLC. I think that's, like, on Z390 for Gigabyte boards, if I'm not mistaken, that was straight up the best LLC setting you could run. When high was ever so slightly worse, and as in, like, you could have honestly run high as well instead. But medium was basically optimal. And yeah, so that's it. Video didn't even make it to it. Video isn't even 2 hours. I'm impressed. So there, that's the overclock. I'm actually surprised the ring went as high as it did. Like, admittedly, right now it's not stable, so I'd have to drop it a bit. But like, this is it. That's all there is to it. And then once you run Linpack, you can go do whatever you want with your system. Because honestly, there's nothing you can run that is as heavy as Linpack. Or at least, I'm not aware of anything as heavy as Linpack. So, yeah. So, you know, just XMP enabled, core voltage set to somewhere. Like, just stay below 1.45 volts on that setting. Also, if you're running one of the more aggressive LLCs, I would actually stay below, like, 1.4. Right? Like, I wouldn't run ultra... Like, you're not going to be able to cool ultra extreme at 1.4 volts. Just straight up, there's no way you're cooling that. Assuming that you're actually doing proper stress testing and not being like some people who run freaking Cinebench and go like, oh, it's stable. And then they're surprised that when they play like Battlefield 4 or I've heard Overwatch, GTA 5, and Battlefield 4 complain about badly stress-tested overclocks a lot. So if you're one of those people where it's like, oh, I ran Cinebench and then Battlefield 4 doesn't run, yeah, it's because Cinebench isn't a freaking stress test. It's a benchmark. There's a big difference. Benchmarks measure performance. Stress tests stress your system and prove stability. So, yeah. This is just kind of like, there's your LLC. We're just going to go through the settings one last time. There's your LLC. Anything between medium and turbo is fine. Extreme and ultra extreme are, in my opinion, a bad idea. Vcore protection, I will hopefully have a video proving that they are a bad idea. Like, I think I've proved it pretty well with the fact that at ultra extreme 1.29 volts, like 4.9 gigahertz cache doesn't even run the freaking desktop. But, I feel like I need more proof than that, and well, we're gonna do that in a later video when I have it more like dialed in, you know, like like I said at the start of the video, I don't want this to be a video where it's like, oh, I already know exactly what the CPU does, so here's a bunch of magic numbers that I pull out of thin air. This is now a stable overclock. No, this is the procedure. You start at a low conservative frequency like 4.8 or 4.7 and a low conservative voltage like 1.4 volts in my case, because I have a big cooling system. If I had a weaker cooling system, I'd be starting at like 1.3, 1.35. Maybe if you had a 10 core, you'd be starting at a lower voltage as well, because again, the 10 core pulls more power for the same amount of, so it gets hotter for the same kind of cooling capacity, right? Because with the 10 core, you literally have like 25% more CPU power consumption. For the core portion of the CPU anyway. And that's the biggest portion of the CPU. Like, most of the CPU's power consumption is the cores. Anyway, so yeah, protections, max them out. Vcore current protection, extreme. CPU Vcore PWM switch rate, you can leave that on auto. I do plan to test that once I get the oscilloscope hooked up, but I'm not going to mess with it right now. Like, it's just adding variables to the mix that I don't want to deal with. Internal VR control, you don't have to go there. They're disabled by default. For the core voltage settings, I would use fixed Vcore, not override or adaptive, because, well, the fixed worked best. So use that. And then in the CPU settings, this is kind of where we get the special stuff. 105 CPU temperature protection for stress testing. If you're not stress test, like if you finished your stress testing procedure, I would set it back down to auto, just so that, you know, your CPU doesn't run at too high temperatures for too long. You don't need to change that. You don't need to change that. You don't need to change that. You might want to disable. Well, you can leave that enabled or whatever. Speed shift, you can leave that enabled. Wait, do I actually have the power savings running? I don't think the system currently idles. I'm not sure. Like, I don't want it to idle properly. I actually kind of wonder how much power it pulls at idle right now. Shouldn't be that much. Like, we can just check in hardware info. Because the thing is, like, your VCCIO and VCCSA, as far as I know, those rails can't idle. So we can just look at, like, the Vcore power consumption at idle. which admittedly hardware info does put load on the system every time it, you know, updates the, like, reads from the sensors. That puts load on the CPU, so it's not truly idle, but we're burning, what, 30 watts of CPU power? Like, I guess if you had all the power savings enabled, you'd be pulling, like, 5 instead. Which actually, we can prove that. Like, I can just power this down and reset the BIOS. So let's do that. I'm going to power down. Clear CMOS. There's a clear CMOS button on the rear I/O of this board, which is another reason why I chose this board for this video. It's very convenient for overclocking. Also, it's worth noting Gigabyte boards, when you reset the BIOS on them, the Z490 ones will automatically restart. So don't get freaked out by that when that happens. It actually surprised me a couple of times. So, yeah, but that's just a thing they do. That's normal. And then they'll power cycle a couple of times, just figuring out what to do. So this is normal. And now it's actually going to fire up for real. And this is just a thing the boards do if you reset the BIOS. So now it's completely stock, like not even XMP enabled, and I do wonder how much power it's pulling at idle. And again, we're going with the VRM power draw reading and not like the other software power draw readings, because the VRM can't really, like, that has to be very accurate. Whereas the other sensors is like, unless you have a laptop, I doubt they're properly configured, because again, desktops don't have batteries and people don't benchmark them for battery lifespan. It idles at 20. So yeah, I guess, I don't, what's the package power draw? Yeah, so CPU package power draw is apparently 5 watts, but for some reason the VRM says it's spitting out 20. I get the feeling that we're probably not idling on 5 watts if the VRM says that it's spitting out 20. Also, I did notice that the input power consumption is wrong, but that's also just a thing that seems to, like, for whatever reason, that doesn't tend to be very accurate most of the time. Like, I'm fully aware that that's incorrect, but the output power consumption, I do trust that quite a bit. I should have hooked up the current clamp for this. I was actually strongly considering having the current clamp, and then I was like, nah, it's a bunch of annoying setup, but yeah. I guess I'll leave a comment under the video or put in the description if I've actually checked the, like, I'll check if the power consumption reading here is more accurate than, like, package power consumption, but it should be. Yeah, because the thing is like, package power consumption, like, I'm not sure how this measurement is supposed to be calculated, but it's like the VRM should not be able to misreport the power consumption that much. Anyway, whereas I have seen, like, package power draw numbers be wildly incorrect. The thing, oh, actually, I think I know what's going on. For whatever reason, well, I mean, the voltage readings here are all wrong, for one thing. Other than that, I'm assuming our vid voltage right now, no, vid is at 1.2 whatever. But the, like, the software Vcore reading, like, why is that so low? Like, how can that possibly be so low while the VRM is reporting 1.25 volts. I don't have the equipment right on hand right now to check that, but I'd assume that there's something weird going on with, like, the voltage measurement, and then the package power draw is incorrect because of that. So anyway, yeah, that's it. There, that's actually it for the video. So oh, actually, I might be able to show you a pretty neat feature of Gigabyte boards, because I did just clear the BIOS. So, oh wait, no, it's probably gone. If we go F4, last known good. Yeah, okay, it's gone. I've restarted the board twice, so it's gone. Last known good can sometimes, like, if you do it right after a clear CMOS, it should pull your last known good settings. So let's punch in those, like, that overclock all over again. So Set base clock to 100, 5.1 CPU ratio, because that's where we ended up. 4.8 for the Uncore, probably because 4.9 wasn't really that stable. 4.8 might be. Avx Offset disabled, because you don't want your CPU randomly slowing down when some piece of software decides to run one thread of AVX instructions, because the entire, like these CPUs, all the cores share the same clock circuit. So if one core decides to downclock, all of them downclock. There's no per core ratio. There is per core turbo, where if one core is running, like if that one specific core is running a workload, then all of the core, like it'll turbo up to a certain speed. Like it's kind of a mess. But basically, yeah, you don't want one random thread of AVX stuff making your entire CPU slow down. That's dumb in my opinion. Temperature protection for stress testing up to 105, like even maybe 110 if you're brave, but I would generally say stick to 105. If you can't cool the CPU even with 105, then you need a bigger cooling system in my opinion. Hyperthreading we can leave auto. Intel speed shift we can leave auto. Offset downband, actually we should disable that. I forgot to disable that, but that should be disabled. CPU EIST function, disabled. Race to halt, disabled. I mean, energy efficient turbo, disabled. Voltage optimization, disabled. Right, all of this, we disable that. We leave those two alone. Frequency, no, active, no, not that one. Where is it? Turbo power limits, disabled. There. And I don't remember if I killed C states, but either way, I don't think this idles. CPU Vcore, I ended up with 1.42. LLC, we went to medium. Max this, max that, and leave everything else alone. That's all you need to do in that menu. And VCCIO, I ended up at 1.4, I think. And System Agent, we were at 1.3 because the board defaults to that when you enable the XMP profile, which if we enable that, 3600 CL14 kit, 1.45 volts. So we're just going to set the memory voltage to 1.45 volts ourselves as well. And that is it. There. I do believe that's the entire overclock at this point. So yeah, and that just took me 2 hours. Actually, well, I've not proved that it's stable, so it doesn't really count. But totally, it took me 2 hours. Also, I was messing around with the LLC for no good reason. Like, there was no need for me to mess with the Ultra Extreme. Like, I wasn't running out of voltage headroom anytime soon. And there goes the capture card again. And we're back. So, one last pass of Linpack, along with hardware info. Oh, and I guess a Cinebench as well for the final settings. Now, the funny thing is, if you have a memory kit that's slower than this kit, because this is for a 2x8 kit at 3600 megahertz, this is a very, very fast kit. But if you have slower memory kits, you might actually be able to run higher ring ratios than what I'm running here, which is kind of funny. All right, now the fan control is back on auto. It's actually doing a decent job, I think. Yeah, Cinebench is ice cold because it's Cinebench. Package power draw reading is ridiculous. While the VRM says that we're pushing 200 watts. This is correct. The package power draw isn't. Like, I don't know why it is that getting power consumption figures, or, well, I expect the VRM reading to be correct. Like, historically, Gigabyte motherboards, if you check the VRM sensors, those are always really accurate. Whereas everything else on motherboards across all vendors is just all over the place. I've had motherboards report that there's less power coming out of the VRM than what's going in. Which is like, or, no, I've had motherboards report that there's more power coming out of the VRM than what was going in. Which, admittedly, this motherboard's kind of doing that as well, but... well, yeah, that's a bit of a problem, but it's not really that big a deal. Anyway, so 5381, which is that's a nice Cinebench score, I guess. I actually have no idea how an 8-core CPU is supposed to score, but that looks good in my books. It's like I don't normally pay that much attention to Cinebench R20 scores, but admittedly, like the CPU started at like 4771. I remember seeing that, or even 4800, and that was with the XMP profile enabled. Just gonna let this pass as well. Yep, let's stop that. Because I just want to pull up the calculator. So that was a 3581, and I'm just going to divide it by 4800 because I wasn't paying that much attention when I first ran it. Wait, what? Oh, what? No, I'm in decimal. Wait. Oh, I'm in programmer. Right. I'm stupid. That's why it was 1. Anyway, 5381 divided by 4800. There, 12% increase in multi-core performance. All it took was 2 hours. It's not actually that much of an achievement. Well, it's not that bad. Like, 12% is decent. That's more than you can get out of any Ryzen CPU. I can tell you that much. That's actually way more than you can get out of any Ryzen CPU. Because Ryzen's normally boost like 4.1-ish, like 4 to 4.1 gigahertz, and getting a Ryzen to go over 4.4 is borderline impossible. Like, Cinebench on Ryzen runs like 4 gigahertz most of the time, and doing 4.4 gigahertz on a Ryzen, like properly stable, very difficult. So, yeah, in my book, that's a win. Like the 12%, that's a lot better than you'd ever get out of any AMD CPU. Actually, not any AMD, but like any Ryzen 3rd gen. Anyway, so now let's see, like, if you were running like 10 gig Linpack, I'm just going to show you what that looks like. So if we set it to 3 loops, I'm not actually going to let it run through all the way. I expect it to crash before it manages that, but this is the thing, is like you're going to have to wait for the memory to ramp up a lot longer, and then when it runs runs for a lot longer. So yeah, we'd be sitting here for a while if I had been using like this right here. I would actually set it to run for like an hour, 2 hours, or I'd probably go with just an hour. I'm kind of like, obviously the longer you run your stress test, the more proof you have that your system is actually fully stable. But I feel like if you don't crash in an hour, you're probably not going to crash in the next 10. So, and there goes the whole thing, which, yeah, that's because we just loaded it up with 10 gigs instead of 4. So now we can start walking down all the now is the part where you get to go and lower all your ratios because you were half-assedly testing with 4 gig, which is why I normally run 3 loops of 10 gigs and then just go up to like 30 loops of 10 gigs when I want to do a full stability check. Or I think it's 40 loops that you need, something like that. Like what it depends on the CPU, because obviously if you have an 8-core, it actually runs a bit slower than with a 10-core. And oh look. Oh, no, it didn't crash the ring. The core crashed. Or, well, actually, I don't know what crashed there, but it wasn't the ring because the reset button was working. Admittedly, we did get a blue screen, so it still could have been a ring. Anyway, well, ring can cause all kinds of issues, but anyway, so yeah, that's it for the video. So, thank you for watching, and I didn't make it to 2 hours. I wasn't actually intentionally trying for that, but yeah, like there. So, that's how I would overclock like any 10th gen Intel CPU on any Gigabyte motherboard. The BIOSes all look the same. The LLC settings are all the same. The voltages available are all the same. Like, I've not changed anything here that is specific to this motherboard. The main advantages I have with this motherboard is the postcode, which we've not needed because we're not doing any memory overclocking. And the reset button's nice. But, you know, your case has one of those. You also have a power button. The clear CMOS on the rear I/O, I'm a big fan of that, of course, but again, we didn't really need that. Reset button was more useful in this scenario. Yeah, like this is how I would do Intel 10th gen overclocking on Gigabyte boards. And I say I because, I don't know, maybe somebody out there has a better method, but Unfortunately, I'm not aware of their method, and they probably don't have a YouTube channel, and so good luck figuring out, like, good luck finding out who has, like, if there is a better method, good luck finding it. No, like, seriously, I'd love to hear about a better method, but this is mine. I trust it a lot. I think this is a good method. Um, yeah, so hopefully this video was helpful to you. I do realize it was 2 hours, but like the funny thing is I have actually helped people overclock over Skype, and normally that takes 30 minutes to an hour anyway. So if you just watch this video at 2 times speed, um, you'll get the same experience as if I just helped you over Skype, assuming you have a Gigabyte motherboard. Minus all of me messing with, well, you wouldn't have the Buildzoid messing with the LLC setting because he's using the board for the first time, like, well, because he doesn't have an oscilloscope. Like, I wanted to use medium the whole time anyway, but, had to check. So, yeah, that's it. Thank you to Gigabyte for the motherboard and Team Group for the memory kit, and to the patrons for the CPU. So if you'd like to support the channel, there's a link to the Patreon down in the description. There's also the AHOC Teespring store, where you can pick up shirts, stickers, posters, the usual YouTuber merch. That also allows me to do things like buy 10700Ks. What else was there? Right, like, share, subscribe. I forgot to do that. I did my outro in like a different order, and now I'm totally thrown off. Yeah, like, share, subscribe. Leave any comments, questions, suggestions down in the comment section below. And there. Now I've said everything that I need to say in the outro, so thanks for watching, and goodbye. Where's that stop? Wrong mouse. There's the stop recording button.